Okie doke. Today we're starting a very exciting chapter. Section is this. Today we're going to start talking about implicit differentiation. What is implicit differentiation? Have you ever heard it? If it's implicit, what is explicit? If something is stated explicitly, what does that mean? It's obvious, yeah. So, what we've done in the past we completed explicit differentiation. Which means y equals some function with respect to x. So if you have a function with the only variable involved is x. What does differentiation mean? What's another name for differentiation? I hear crickets. What's another word? What do we use other than differentiation when we differentiate? Well, yes, but where do we find when we find the limit? Yes, so the slope, it starts with a D. The word I'm looking for starts with a D. Yes. When we say, yeah, because all that stuff is true. When we're talking about differentiation, we're talking about derivative. So when we say explicit differentiation, that means we're taking derivatives with respect to x. Example, if I give you this function here, what's that asking for? It's asking for y prime. So what is y prime? That's the first derivative. What is this asking for? The second derivative, which will be what? So that's what we did in the past. We will examine functions implicitly. Implicitly means implied. So it's a function with respect to x, but it's going to look different. Here's an example. This is an implicit differentiation, which means we have x and y in the same equation. And if we set it equal to 0, that means we're looking for a specific point. We're looking for the vertices, the highest or lowest points. Other examples could be set that equal to 0. These are implicit differentiation. They imply differentiation implicitly, where x is a variable as well as y. Well, y is a function of x also. You can solve these. You can solve these two ways. Find me the first derivative. Find dy dx. We're going to do it two ways. We're first going to solve it the way we've done it in the past, and then we're going to teach you how to solve it implicitly, where x and y are both on the same side. Because remember, I'm asking to find that, which is the same thing as y prime. Okay. Explicitly, well, how do we have to set it up if we're going to solve it explicitly? Which one? Eventually, but not yet. We have to first get y by itself. Remember, explicitly, we had this function. Y equals some function with respect to x. So we add x to both sides. Square root both sides. And that gives us y equals plus or minus square root of x. Can we solve it? Can we take the derivative? Let's look at just the positive side. Well, let's do both, actually. So we're going to take both sides. We're going to take the positive radical and the negative radical. How would you find the derivative of this? What do you have to do first? Very good. You have to rewrite this as an exponent. Now we take a derivative of it. Bring that down. What happens to the exponent? Subtract what? Subtract by 1, not 1/2, yes. So you're subtracting by 2 over 2, so you get negative 1/2 on top. So this one becomes so there's the first derivative of the positive side. We do the same thing to the other side. dy dx. And the exponent, subtract 1, which is 2 over 2. So far, so good? Now, this is also giving us a hint on how we're going to do implicit differentiation. When we took a derivative of y, what happened? It became dy dx. So we have to remember this. Y prime is the same thing as dy dx. We do the same example, but we're going to do this now implicitly. When we do implicit differentiation, we just go across the board and take a derivative of everything as we get to. What's the derivative of y squared? Two y, but we have to take a derivative of y with respect to x. Take the derivative of y, we get dy dx. We took a derivative of the outside. Remember the power rule? Take derivative of the outside. Now we take a derivative of the inside. The derivative of y is dy dx. What's the derivative of x? Now we're solving for dy dx. So we have to add 1 to both sides. And divide by 2y. Are we done? No. What does y equal? We have to go back up to here. We have to add x to both sides and square root it. So y is equal to the plus or minus radical x. Isn't that what we found out last time? One over 2x positive, negative 1 over 2x. Positive, negative 1 over 2x, or radical x, let's say. Which method's faster? Implicit is a lot faster because it does it all in one swoop. Let's see another example. Find dy dx. At the point 3, negative 4. Okay. What is this looking for? What does this find? You said it earlier. The derivative is the slope. What is this equation defining? Maybe if we did this, if we added 25 to both sides. That look familiar? Equation of a circle with radius what? If r squared equals 25, r equals 5. So this is the equation of a circle, radius 5, centered at 0, 0, at the origin. So we know we have a circle like this. What we have to do first is figure out, is that point on the function, on the graph? If it's not, then we can't figure it out. Why? If this point is not on the graph, we can't find it. Why? This is a theory question. It has to do with this. If it's not on the graph, if it's just a point out here, what's the slope of the line going through that point? It could be anything. It's an infinite number of slopes. But if the point is on the graph itself, then what this dy dx is finding is the slope of the line tangent to the curve at that point. So that's what this whole thing means here. Dy dx means slope of the line tangent to the curve at that point. So we first have to check, is it on the graph? Plug it in there. 3 squared plus negative 4 squared, does it equal 25? Yes. So that point does exist on the graph. That's the first thing we have to figure out. Because that exists, now we can find the derivative. So let's find the derivative. What's the derivative of x squared? What's the derivative of y squared? What is it? 2y. That's it? 2y dy dx. Because remember, y is a function of x. Derivative of 25? 0. Now what are you going to do? We're going to solve for dy dx. So we subtract 2x from both sides. Then divide by 2y both sides. Use cancel. Are we done? What do we have to do? Yeah, we have to find out what y is. We have to solve for y. And it goes there. X squared plus y squared is 25. Subtract x squared. Square root. Now we found the derivative at that point. Remember, we're looking at it from the point 3, negative 4. Use either of these two equations. Since the point is given to you, we could have used this one. Negative 3 over negative 4 makes it 3/4. That's the rate of change at that point. Or we could just plug 3 inside here. 3 over 25 minus 3 squared. 3 over 25 minus 9. 3 over radical 16. 3 over 4. So if you're given a point, you can use this equation. If you're not given a point, then you have to put it all in place of x, because that's where it's differentiating from. So far so good? So what do we know so far we have to do? Whenever you take a derivative of y, what do you have to do? What do you have to put in place of a derivative of y? What's the derivative of y cubed? dy dx. Whenever you take a derivative of y, always put a dy dx behind it. That's the only real change you have to do. Everything else is the same. And we could do multiple derivatives of this stuff also. Another example. We can use trig functions. What's my first step? What's the derivative of the left side? Two y dy dx. Whenever you take a derivative of y, put a dy dx behind it. So derivative of x squared? Now what do we do? What's the derivative of sine xy? What's that? But you have to also, yes, but you also have to take a derivative of the inside. So we have sine xy. The derivative of sine is cosine times the derivative of the inside. It's a product, remember? The derivative of x is derivative of y. We have to do the fishy thing. So y plus x dy dx Now what do you got to do? What are we solving for? Solving for dy dx. So we have to get dy dx is on one side, but this side's in a parenthesis, so we have to distribute. So it's y cosine xy plus x dy dx cosine xy. I got rid of the parentheses. I have to move all the dy dx's to one side. So I've got to move this. I've got to subtract x dy dx cosine from both sides. So left side we have 2y dy dx minus x dy dx cosine xy equals 2x plus y cosine xy. Next step. If you divide it by 2y, then you'll still have dx dy in both of these places. Factor out, yeah. Because we have to get this by itself, so we factor out dy dx. It gives us 2y minus x cosine xy. So now we only have this at one place. We have to get rid of this. How do you get rid of that? Divide it. Divide both sides by 2y minus x cosine xy. 2y minus x cosine xy. So the derivative is difficult about this one. A lot of steps. What kind of steps? Algebraic. Because the calculus part, only thing that's ever used for is take the initial derivative. Once you take the derivative and put dy dx everywhere, the rest is algebra. And it's a bunch of moving around, right? A lot of writing. Is there a way you could have made it easier to write all this stuff? Instead of writing dy dx everywhere, you could just put y prime. And that would have made writing a lot of this stuff a lot easier. But you could get confused where it is. We got a couple more, so don't worry about it. Let me see. Which one I'm going to use next. Zzz. 2x cubed minus 3y squared equals 8. What is that asking for? So, how do we do that? What do we have to do first? Let's find the first derivative first, right? So. First derivative. What's the derivative of 2x cubed? Derivative of 3y squared? dy dx, very good. Yes, whenever you take a derivative of y, after you do all that other stuff, you have to do dy dx behind it. Yes. Yes, I would highly suggest that. So in this one, we have to solve for the first derivative, dy dx. subtract 6x squared from both sides. Sorry for this. Change the signs. They're both going to be positive. Divide by 6y. X squared over y. Now what do you do? Do it again. We got to do the quotient rule. Derivative of x squared. Derivative of y. 1 dy dx. So just dy dx. Since it's the quotient, we subtract. It's y times 2x, so it's 2xy minus x squared y prime, this is y prime, all over y squared. We done? What does y prime equal? Two xy minus x squared over y squared. It's all algebra from here on out. X to the fourth over y. How do we combine the numerator? What do we have to do with this one? It's over 1 right now. We have to get a common denominator. Yes. So it's 2xy squared over y minus x to the fourth over y squared. Now we can combine the two top ones. 2xy squared minus x to the fourth take the top, leave it alone, multiply by the flip of the bottom, there's a derivative, second derivative. what does this example show us? Is when you take higher derivatives, you have to substitute prior derivatives into that equation. So if we're going to take the third derivative, we have some place inside here that would have the first derivative or second derivative in it, and we have to plug those in there. Difficulty level? What's difficult about these? What's that? Yeah, exactly. And all that just takes is practice. So be very, very careful as you move things around. And I don't mind next class just doing a whole bunch, just going back to the end of this section and just do 20, 30 problems. I don't mind that at all. So just for practice. The next topic we're going to talk about in this section are lenses, tangent lines, and normal lines. When you talk about lenses, talk about optics. Have an entry point for the light. The line going straight through there is called the normal line. It's perpendicular to the tangent line. Perpendicular. Now, when light comes in, this is the light ray. Does it go straight through the lens or does it diffract? In other words, if we had an angle here, say angle alpha, is it going to be the same angle on the other side? Or will it bend? Why does it bend? From the normal line. Does A equal B or does A not equal B? Ever look inside a pond and you see a coin? Is it straight ahead of you or do you have to go down lower to pick it up? Let's go lower. It's called diffraction. And the reason an eye does that, because inside an eye, it's called an aqueous humor. It means it's a liquid medium inside there. So when light comes in, it bends off of the normal, which is the entryway. So we are going to talk about angles A and B from the normal. The refracted line. Or refraction. Let me look for an example here. Show that the point 2,4 as on the curve x cubed plus y squared minus 9xy equals 0. Y cubed. Then find the tangent line and normal line to the curve. That point. What do you think this graph's going to look like? It's a cubic function. Like that. It's 2,4. So, there's our point. What is our normal line to that point? What does the normal line look like? Well, first off, to find the normal line, we have to find the line tangent. The line tangent looks like this, right? So the normal line is perpendicular to it. So we have to find both of those. How do we do that? First off, part A, show that the point 2,4 lies on the curve. How do we do that? X cubed plus y cubed minus 9xy equals 0 at 2,4. So, 2 cubed plus 4 cubed minus 9 times 2 times 4. Does that equal 0? Cubed is 4 cubed is 8 times 9 is What does that tell us? Points on the graph. So we can go ahead and find what we need to. We got this? Yeah, so if we equal 0 to 0. Oop, I need a function. Function is x cubed plus y cubed minus 9xy equals 0. We find tangent line, normal line. How do we find the tangent line? What's that going to find us? It's going to find us the slope at that point. So let's find dy dx. So the first step, find dy dx, or y prime. Go ahead and do that first. So the derivative of x cubed is 3x squared. Derivative of y cubed, 3y squared. dy dx. Minus 9. This is a product, so we got to do the product rule. Derivative of x is 1, derivative of y is dy dx. With a plus between there. So it's y plus x dy dx. Equals 0. No, I don't have too many warm and fuzzies seeing how many pencils moving now. Then what's my next step? Get rid of the parentheses. Yeah. So we have 3x squared, 3y squared, dy dx, 9y minus 9x dy dx equals 0. Now what? So anything that doesn't have dy dx goes to the other side. That's got to move, and that's got to move. So we subtract 3x squared, and we add 9y. dy dx. Negative 3x squared plus 9y. Next up, factor out the dx dy. Very good, because that's what we're looking for. 3y squared minus 9x. Divide both sides by 3y squared minus 9x. The derivative equals negative 3x squared plus 9y over 3y squared minus 9x. Can we simplify it any? No, we can factor out a 3 first, on top and bottom. Before you cancel, you have to factor it out first. Negative x squared plus 3y, y squared minus 9x. 3's cancel. So our derivative, that's 3. That's our derivative. What do we do with it? What does it find for us? Why do we need it? Very good. It gives us the slope when we plug in the point. The point was 2, 4. But it gives us the slope at the point of what kind of line? What's the name of it? Tangent line. Very good. Good. Together you guys got it. Yes. It's a tangent line. So we got x is 2, so it's 2 squared, 3 times 4, 4 squared minus 3 times 2. So it's 2 squared is 4, so it's negative 4 plus 12, 16 minus 6, 8 over 10, 5. It's the slope of the line tangent to the curve at 2, 4. Is that all we needed to find? Yes. The first thing we have to find is the equation of the tangent line. We have the slope, which is 4 over 5, and we have a point, which is 2, 4. We need to have it in this form, equation of a line. So what's the only thing we're missing? Yeah, we're only missing b, because the y, this is x and this is y, so it's 4 equals 4 over 5 times 2 plus b. Since nothing cancels, I don't like dealing with fractions, so I get rid of the fractions. What's the LCD? The LCD, only the number is 5. So if we multiply each term by 5, we get 20. The 5's cancel, so 4 times 2 is 8. That way you don't have to worry about finding the common denominator, adding, subtracting, and then worry about all that stuff. Get rid of the fractions first. If the answer is going to be a fraction, it'll be there at the end. Subtract 8. And divide by 5. So my y-intercept is 12 over 5. So the equation of the tangent line is what's your slope? 4 over 5. And the y-intercept is 12 over 5. That's to find the equation of the line tangent, because that's what the first derivative gives us. Now we have to find the normal line, the equation of the line normal to the curve at that point. How do we do that? What's the relationship of the line tangent and the line normal? They're perpendicular, which means what about their slopes? Negative reciprocals. Yes, they're exactly. It's a perfect opposite. They're negative reciprocals of each other. So B is equation of the normal line. So we know the slope of the tangent line is 4 over 5. Slope of the normal line is perpendicular to the tangent line. It's negative 5 over 4. The slope of the tangent line is 4 over 5. The slope of the normal line is negative 5 over 4. So we have that. And we have the point it goes through. So we do the same thing. Find y equals mx plus b. closest to the normal line. Equals negative 5 over 4 times 2 plus b. Fortunately, these two can cancel, so 2 goes into 4 twice. The LCD is 2, so I multiply everybody by 2. Those cancel. 2 times 4 is 8. 5 times 2b. I hate fractions, so I get rid of them and put them at the end. Add 5 to both sides. 13 equals 2b. b equals 13 over 2. Negative 5 over 4, x plus 13 over 2. And there's the equation of the line, normal to the curve. And later on in calculus 2, calculus 3, the reason they call it normal now, it has another name. It's called orthogonal. But when we say normal or orthogonal, it means it's perpendicular to the tangent line of any curve. What do y'all think? Painful? It's algebra. It's the review of the algebra and the step-by-step stuff. You have to be very careful. The calculus part is going to be the first part. Once you get the ball rolling, that's calculus. Then the rest to solve it is algebra. Look, try a couple of problems on your own before we meet again on Wednesday. And then on Wednesday, I'll just put the end of the section questions up there and let you pick some. And we'll do those. All right? Just to get practice on it.